Okay, so there is a lot of information within the first unit that talks about different aspects and rating things, and it's really, really important stuff. But also, I don't want to just sit and read a fact sheet off because then pretty soon you're gonna be like, oh, there's a video on McBride's I gotta watch in order to do some notes on it. And, I don't want to write. All he does is just talk about the fact sheet. I don't want to do that to you. I think that's a waste of time. So I'm going to point to some important things that, well, I guess I should say, as far as work goes, as far as what you're doing out there in the real world, what I'm going to do is say, hey, these things are more important. So you have to know them for the test. You have to know that, and that's awesome, because I can't tell you how often I've had to use information like this, and most students and most people, a lot of people in tech don't even know. They don't even get it. They don't even bother. So it really is super helpful, but I'm going to focus on some. I think it's actually interesting, the sound and video stuff. You meet those people that are like, oh man, it's got to sound, it's got to be this bit rate. They don't even know what any of that means. They just are, talking about one little thing that they know. But basically, once you take a sound or video and you put it into a digital format, you have these attributes here that affect what you're going to see or hear. That's what you're seeing on this. If it's video, you've got how much color is there available. There's a huge difference between only having 256 colors available or having billions, millions of colors available. But the current resolutions are not resolutions, color depth is so high that you can't tell the difference. So some people will say, oh, it's got this color depth is so much better. It's a 32-bit color depth. And it's like, yeah, you can't see it anyway. So it doesn't matter. All right, resolution. This is an important one. How many pixels, wide and tall, length times width. I wish they wouldn't try to make this a little easier. You're doing that math and you're having a rectangle and it's length times width. I mean, width times length, either way you want to look at it. And that gives you the area, right? That's a simple math problem that you probably did in 4th grade. I don't know. But that's the resolution. So the resolution is that area that's in between my set of fingers, right? So coming from here all the way over here, that's one number, and then down is another number, times this gives you the bits or the pixels that are there, a part of that. And so 4K means I've got 4,000 pixels inside of that area that I'm displaying. And I wish they would just actually select some way that they want to rate it and say it's this times this, which is how we do it in computers, right? So my resolution is 6,000 by 3,000. But in the pictures, like taking photos and also dealing with my monitor at home that's really called a TV set, they deal with pixels a lot. So remember, length times width gives you the pixels that are in the middle. So resolution will usually be this by that, and that's how we say the X. This by that. Anyway, sampling rate is actually how often it's going to sample what's happening. So another setting that affects sound recording quality is a sample rate. We talk in analog. What that means is we talk in a waveform, right? We don't talk in binary. We don't do beep, 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 beep. We don't do that. We have a fluctuation, and that's actually along the sine wave that happens. And the sampling rate is how often it's going to take a sample from that sine wave. The more samples you're taking, the more accurate it is to the actual sine wave, to what you're actually saying or recording. So the sampling rate becomes really important. But then at some point, for instance, if we're just doing an audio recording like this, it could be really low. This would be a mono sound sampling. And it's just fine. You can hear the person just fine. But then if we're talking about music, we want more of those sampled. Let's take a look at a little bit on graphics, right? Here's the resolutions we were talking about. This should be an X in the middle. not a little square with a question mark in it. It should be an XXX. So if you're dealing with 4K, that's 3,840 times 2,160. And that deals with 4,000 pixels in the middle. That's what that's talking about. The aspect ratio is dealing with whether or not we're talking about square or widescreen. And so we see the old standards, those are more square. And then our widescreen aspect for TVs, which has become very, very important. See, so this is, you see a 1080p or 1080 progressive. The other number there is a 1920 times 1080, and that'll give you how many pixels are in there. But the format of it is 16 by 9. And then, of course, if you're dealing with movies, it's 16 by 10. And there you are for the color depths that I was talking about. Having to record only 8 bits, we get 256 possible colors. And then we went to 16 bits that gave us that number. And then once we get into 24 and 32, we really are at that point where our eye cannot distinguish as many colors as we can actually display. And then refresh rate is also really important, not as important as it used to be. Refresh rate, for instance, fast moving graphics require a refresh rate of 120 hertz or higher. So that is your electric signal coming in. I've got a monitor right here in front of me and it's nice and bright and I can't see any flicker or anything on it. And that's because that electricity that's coming in and then hitting these pixels is refreshing the pixels so quickly, whether it's red or white or yellow or green or blue. It's refreshing that so quick that my eye can't pick up on it. And so now you start to move a graphic across that. And so you got a spaceship flying from one side to the other. Well, if it's flying super fast, then the pixels have a hard time keeping up with that on the refresh rate. And that's why really we see that in TV, right? We're watching TV or something and they're like, oh, this is, I can't remember what they call it on the TV side. But basically what you need to know is that if you got 120 hertz or higher, your refresh rate is so fast that you don't get any little jitter. You don't see any kind of blurring or strainness. That's why if you were at somebody's house and you're looking at their old LCD TV that they got 12, 15 years ago, it cost them a ton of money. And so they're going to just run it until it dies. They're probably at lesser, like a 50 hertz. And when you watch some game or something, it's like, your eyes are kind of like, that's kind of weird. Just don't, or you watch a super action movie and there's kind of a blur to it because that refresh rate can't keep up with it. So normally you want something that's 60 hertz to 120 hertz. Gamers will go out and spend a ton of money on 140 hertz graphics, and that does not do anything for you unless you're dealing with some kind of fast movement on the screen. So when you see somebody and they're like, whoa, this must be 140 hertz and nothing's moving on the screen, it's like that doesn't matter, dude. You can't tell any difference. I could have a 70 hertz and you wouldn't know at all. Maybe the colors are better for some other reason, like the color depth is better, but that's not having anything to do with that hertz. That's one of the best things about knowing this stuff, is because when you go out and commercially have to buy something, you're really looking for certain specifics instead of the advertising that they're giving you. So if somebody has decided to play some old retro game and it's super old, I don't think your 140 hertz monitor is really going to help you. But newer games, right, that is going to help you because they are employing super fast moving graphics in order to display what you want to see. And then the rest of this is how do we actually display that information out there for people, right? Is it a screen that they're using? Is it a projector that they're using? That kind of thing.